So for rigid body motion in 2D, we have translation, rotation about a fixed axis, and general plane motion. And we can do these both in 2D or in 3D, and for 3D we'll just do the general plane motion and rotation about a fixed axis. The translation will only be in 2D. And this is, in your textbook, this is chapters 11, or sections 11.1 to 11.3. For any of you that have the old textbook, it's chapters 16.1 to 16.3. That's the old 14th edition. So let's start out by talking a little bit about translation, and then we'll get into the rotation about a fixed axis. So for translation, we basically have a body that is just moving just in that XY space. So if we look at point A and point B, then those points are still on that rigid body at the same places. And we can see how that moves in time. So you can see point A, sort of as this rigid body moves, it moves along this path, and B is that path. For these, you treat them as particle kinematics, so we are going to be getting some into the particle kinematics, but basically the change in the position at A equals the change in the position of B. That makes sense because it's all part of that same body, right? We also know that the velocity of A is going to equal the velocity of B, and the acceleration of A is going to equal the acceleration of B. For this, we want to treat this as particle kinematics. And the main equations here are those ones that I just mentioned. So the velocity equals the change in the position over the change in time, or the acceleration equals the change in velocity over the change in time. You may want to go back and look into some of those equations for particle kinematics. Maybe I'll write them out here. All right, so we've got these two equations, and then the other one is A ds equals, or ADR, I guess we have here. Let's see. Equals V dV. And you can work through these equations, and these are out of chapter 9 in your textbook. But when we have constant acceleration, so the acceleration doesn't change. The guiding equation is the velocity equals the initial velocity plus the constant acceleration times time. Another equation for constant acceleration is the position, which we'll do it as R because that's what it is here. R equals R naught. So that's the position plus the velocity the initial velocity times time, plus 1/2 times that constant acceleration times time squared. And R is the position. Sometimes you'll see that written as S also, or X. And then for the third equation for constant acceleration is that the velocity squared equals the initial velocity squared plus 2ac, so that constant acceleration of r minus r naught. So that change in position. So if this doesn't seem familiar to you, you may want to go back in the textbook and make sure you have some understanding of that. The next thing